I'm going to teach here the basics of the Nix syntax. Nix, or Nix, is the programming language for the Nix package manager. The Nix package manager is the default package manager for the NixOS Linux distro, but it can also be used in Ubuntu and in Mac and in Fedora. It is a generic package manager. Needless to say, being a package manager, it serves similar, if not more powerful rule than what a dpkg in Ubuntu or the RPM in Debian is doing to manage packages of softwares inside an operating system, meaning to allow a user to install stuff inside their Linux. But in contrast to dpkg or RPM, the Nix does it in a programmable way. So you program in what we call as expressions, the Nix expression. And because of this programmable nature of Nix has a syntax. And we must understand the basic of this syntax. Like in any programming language, the Nix package manager has a REPL. It has now start.REPL. So the purpose here is to learn the basics of the Nix syntax. The Nix syntax follows a functional programming paradigm, so it is very different from the imperative paradigm that we used to know. Nevertheless, I will start my tutorial with what most of us are familiar with. For example, I will start it with an assignment. Although this is not allowed in a functional programming, but because we are inside the REPL, we can do it. So I will assign a to the value of 5. Now the variable a is 5, and if we check it, and indeed it is 5. Next, I will assign b to the value of 3. And now we have two variables. We can add these two variables, and we get 8. We can subtract them, and we get 2. We can divide them, but we need to put a white space in order to make it a division operator. Otherwise, the forward slash will be interpreted as a path separator. So without a white space, it is not division. So, having seen these basics, and this is the hello world of imperative programming, which is assigning values to variables and using arithmetic to add variables. Let us now create a function. Let us create a function that accepts one parameter and increments that parameter. Let f be the name of that function, and the function accepts a parameter, say n, and increments 1 to that parameter, n plus 1. We just created a function that accepts one parameter that increments its parameter. Let us give it a test. This is how we invoke the function, and we pass 3 as the argument. There are no parentheses, just space. And this should give 4. 3 is the argument, and 3 is incremented by 1 because that is how we define the function, and it gave 4. Just gave it one more test. Let us create another function, JSON goat, that subtracts 1 to the parameter. It just gave it a test. Seven. Alright. So we have two functions now, f and j, which does slightly different things. The one adds 1 to the function, then the second subtracts 1. Functional programming. In the functional programming, functions are first-class citizens. So you can pass functions as parameter to functions. So let us create another function m, whose first argument is a function. Let us say b, or just a, and whose second argument is an integer. And the behavior of m is that it applies the function to the integer. So since a is the function, then we call this function and we pass it its applied integer. So m is now a function that accepts two arguments. The first argument is a function, and the second argument is an integer, and the behavior of m is such that it applies the function to the integer. So let us give it a test, m, and we already have previously existing functions f and j, so let us pass f, and we pass an integer, say 2. We already know that f is a function that adds increments in integer. And indeed, we have the result 3 because f is applied to 2. On the other hand, if we pass j, then we get a 1 because g is applied to 2 and in effect subtracting 2 by 1. So we can see now that m is a function that accepts two arguments, wherein the first argument is a function. Next also accepts anonymous function. So these are functions that are not assigned to any variable but declared on the fly. So let us give it a try. Let us create an anonymous function that doubles a number. Now let us pass it on the fly. Okay. So we pass an anonymous function that multiplies by 2 whatever is given to it, and we pass the second argument 7, and we have 14. So here we pass f, which is a named function. It is a name because it's assigned to f. Here we pass g, but here we pass an anonymous function, which is denoted by the parentheses, and a function that is declared on the fly. So m accepts anonymous function and applies that anonymous function to 7, which multiplies 7 by 2. So this gives you a taste of what functional programming is all about. If you know how to program in Haskell, then all of this should be very familiar and easy. But if not, then understanding these concepts takes some time. It takes a lot of time to get your head around this. To summarize, what I have explained here is the Nix Package Manager, which has a functional programming syntax. And I have just shown you in the Hello World way of describing it, how and the very basic fundamentals of the Nix syntax, although assignment operation such as when I did n equals 7 is really not allowed in functional programming, but we are able to do that here because we are inside the REPL. Later I will explain more on how to do things in the next REPL in my next installment. So don't forget to subscribe, and this is your mobile teacher signing off. Good luck and happy coding.